In previous videos, we've looked at annuities, savings annuities, where we start with $0, make regular deposits, and end up with a big pot of money. And payout annuities, where we have a big pot of money and we make withdrawals until we deplete it to zero. This video, we're looking at amortized loans. And you might be wondering, well, what's the connection? Well, it turns out that amortized loans follow the payout annuity formulas. The reason for that is we need to look at it from the bank's perspective. As the bank is concerned, they're depositing a big chunk of money with us, and then they're going to make regular withdrawals, the payments we're sending them, until that is down to zero. So we are paying them the interest for the use of that money that they gave us. Here's an example. Janine bought $3,000 of new furniture on credit. Her credit score isn't good, so she's charged 16% interest. She's agreed to pay it off over 2 years, and we want to know how much she's going to have to pay every month. We're asking for the payment, which means we're asking for the D, not the P, the D, when you're looking for that regular deposit or withdrawal. So here's the formula we're going to use. It's the same payout annuity formula we've used before, but we're using it in terms of a loan. In this case, the P sub 0 is how much the loan is for, $3,000. The interest rate, 16%, so 0.16, and K is 1 because she's making monthly payments. Well, the N is the only other piece we need, and that's 2 because it says she's going to pay it off over 2 years. So I very carefully plugged in all those numbers into my formula. Then I'm going to very carefully plug it into my calculator, and we should come up with $146.89 every month. It always is a question in my head, well, then how much did she actually pay for this furniture? She makes this monthly payment for 2 years. So every single month for 2 years, so $146.89 times 12 months in a year times 2 years means she's paying $3,525.36 for her $3,000 worth of furniture. This is just a good example of why, if you can, save your money first, then go buy it. Not always possible, but if you can, you will save yourself a lot. All right, when I'm talking about homes, most of us are going to have to get a loan. So here's an example involving that. It says you can afford $1,100 a month for a house payment. You found a bank that offers a 30-year, 3.5% interest loan. How big of a loan can you take out? Okay, well, they're telling me how much I can pay, that monthly payment. They're telling me I know the D, but what I don't know is the big pot of money the bank's going to deposit with me. So I don't know the P sub 0 on this one, right? Does that make sense? So how much of the loan is going to be the P sub 0. I know the rest of it. D is $1,100. It says 30 years, so N is 30. Interest rate, 3.5%, so 0.035. And K, we're making monthly payments, so K is going to be 12. Plug that into my formula, carefully plug that into my calculator, and it turns out we could get a loan of $244,964.48. Well, here's a couple more questions. What's the total you're actually going to pay for that house? Well, how do you come up with that? Well, how much are you paying every month? You're paying $1,100. How long are you doing that for? It says 30 years. So we're going to take 1,100 times 12 times 30 means we're going to pay $396,000 in total to the bank. So how much did the bank make off of this deal? Well, we take what we paid minus what they originally gave us, the loan, and it turns out they made over $151,000 on that loan. That is, of course, over the course of 30 years, but seems kind of crazy to me. Let's take a look at one more. It says, you buy a home for $129,000 after paying 15% down. You finance the rest at 4% for 20 years. What will your monthly payments be? All right, so this time they're telling me the big price, and I'm supposed to figure out the payment. So I'm going to be solving for D on this one. But I don't jump there. There is that little statement that says after paying 15% down. So it's 15% of the purchase price. So the first thing we actually have to calculate is the down payment. If If you recall from our previous units, to calculate a percentage of something, you multiply. So 0.15 times 129,000 means we're going to pay $19,350 down. That's going to be subtracted off the purchase price so that our loan actually is not going to be $129,000. It's going to be less the down payment, or $109,650. Okay, that's what my piece of zero should be, right, after the down payment. Then we know our interest rate, 4%. We know our N is 20 and our K is 12 because we're making monthly payments, and we plug it into our formula. So it will look like this. 109,650 times the quantity, 0.04 over 12, all divided by, big parenthesis, 1 minus, parenthesis, 1 plus 0.04 divided by 12 raised to the minus 20 times 12. Very, very carefully put that into your calculator, and you come up with $664.46 for your monthly payment. Now, what about how much interest you're paying? Well, just like before, we'll take our monthly payment times 12 times 20, because that's how many years the loan is for, minus the original amount of the loan. Turns out we're paying $49,820.40 in interest for this loan. Not quite as extreme as the other one, but still a lot of money. Let me know if you have any questions.